In the last class, we were discussing about how can we select a cluster representative. And today we are going to discuss about how can we do cluster-based retrieval. So, cluster-based retrieval is based on cluster hypothesis. We all know that what is a cluster hypothesis. Cluster hypothesis states that closely associated documents tend to be relevant to the same request. That is what we mean by the cluster hypothesis. Here the clustering picks out closely associated documents and groups them together to form one cluster. So one cluster contains only related documents. Hope it is clear. So here we are having a hierarchical classification of documents. We discussed that in the last module. How can we hierarchically classify some clusters? So here we are going to discuss about a simple searching strategy that can be applied to a cluster. Here in this figure, you can see lots of clusters, cluster 0, then 1, 2, 3, 4, 5, 6, 7. All these clusters are arranged hierarchically. I already told you that we already discussed about this. How can we arrange clusters as hierarchically in the last module. Here the search starts at the root of the tree. Suppose a query comes into this scenario, we will first check that query with the node 0. That means the cluster 0. It proceeds by evaluating a matching function at the nodes immediately descendant from 0. Here in the example 1 and 2. First we will start the search at 0, then we'll descend to 1 and 2, then from 2 to 3 and 4, then from 4 to 5, 6, 7. Like that we will be proceeding our process. Here this pattern repeats itself down the tree. Then the search is directed by a decision rule. There should be a decision rule which on the basis of comparing the values of a matching function at each stage decides which node to expand further. In each stage, by using some decision rules, we will be deciding which node to expand further or to which branch we need to go for the next search. So it is also necessary to have a stopping rule too, which terminates the search and forces a retrieval. So here in this picture, 1, 2, 3, in this hierarchical pictures, we can see 7 clusters. They are connected together. And here we are using one decision rule. Expand the node corresponding to the maximum value of the matching function achieved within a filial set. Then here the stopping rule is we will stop the procedure if the current maximum is less than the previous maximum. Suppose the value of the matching function is giving a less value than the previous value, then we can stop our search and we can retrieve the previous cluster. Like that, the cluster-based retrieval is happening here. So in this picture, the search will start at 0, then it will go to 1, then 2, then from 2 to 3, then 2 to 4, then 4 to 5, 4 to 6, 4 to 7, like that. Here the decision rule is the matching function. Here we will calculate the matching function, MQ0, then MQ1, then MQ2, then we will continue our search according to the decision. If MQ2, that is the matching function of the query with the cluster 2 greater than matching function of query with the cluster 1, that is MQ1. And MQ2 is greater than MQ0. So first we will calculate MQ0, MQ1, MQ2. If this particular condition is satisfied, then only we will be continuing our search. Again in the second layer, we will be calculating MQ3, MQ4 also. Then we will be searching, we will be comparing their values. That is, if MQ4 greater than MQ3 and MQ4 greater than MQ2. If that condition is satisfied, again we will be continuing our searching. In the third layer, we will be again calculating MQ5, MQ6 and MQ7. If those values are less than MQ4, that is, current maximum is less than the previous maximum, then we will be stopping our searching and we will be retrieving the cluster 4, because that cluster 4, its matching function has got the maximum value. If a particular matching function has got maximum value, that means it is more related to the query. Then we will be retrieving the cluster 4. This is actually the searching function happening inside a hierarchical clustering scenario. Hope it is clear. So we should have a decision rule and a stopping rule. Here the decision rule is that comparing of matching function. Hope it is clear. So in this scenario, we will be assuming that effective retrieval can be achieved by finding just one cluster. That is the effective retrieval strategy. Again, we will be assuming that each cluster can be adequately represented by a cluster representative for the purpose of locating the cluster containing the relevant documents. We will be only calculating the matching function with the query to that particular representative only. If the matching function is not unique, we need to do some special actions like look ahead. Here the look ahead means it is mainly used in backtracking algorithms that we will be discussing later. What is that backtracking algorithms and all. And it is a sub-procedure. This look ahead function is a sub-procedure to foresee the effects of choosing a branching variable and evaluate one of its values. We will be foreseeing if you select that particular branch. If we are in second cluster, what may happen if we select the branch 3? That particular sub-procedure is known as look ahead. Then the fourth point is the search always terminates and will retrieve at least one document. There should be stopping. This search shouldn't be an infinite one. There should be some stopping criteria and to retrieve at least one document. Hope it is clear. Here in this search, we begin our search from the root. This particular method is called top-down search. We started our search from the top, then we will be going all the branches. So a generalization of this search is to allow search to proceed down more than one branch of this tree, so as to allow retrieval of more than one cluster. So there may be a scenario, there may be a chance of getting more than one cluster as our result. When the search strategy estimates, based on the current value of the matching function, that further progress down a branch is a waste of time. If the decision rule decides or it foresees, that is the waste of time if we go to the next branch. At that point, it may or may not retrieve the current cluster. The search then returns to a previous branching point. If we foresee, that is a pure waste. If you go to the next branch, then we will backtrack. We will return to the previous branching point and takes an alternative branch down the tree. This technique is called backtracking. Suppose we foresee that is a wastage. If you go to a particular branch, we will go back to the previous node and we will select the next branch. This particular method is called the backtracking. Hope it is clear. Then like this top-down approach, we will be having another thing. That is a contradictory one, that is bottom-up search. That is pure reverse of the first process. We will be starting from any of the leaf node and we will be going upwards. Hope it is clear. In bottom-up search is one which enters the tree at one of its terminal nodes and proceeds in upward direction towards the root of the tree. Root is the last and final node. We will be continuing our search from the leaf node to the root. In this way, it will pass through a sequence of nested clusters of increasing size. Here, a decision rule is not required. We only need a stopping rule, which could be simply a cutoff. Here, a typical search should seek the largest cluster containing the document represented by the starting node and not exceeding the cutoff in size. Once that large cluster is found, a set of document in it is retrieved. In this scenario, in this method, to initiate the search in response to a request, it is necessary to know in advance one terminal node appropriate for that request. We need to first find the terminal node which is appropriate for this request. Then we will be searching in an upward direction to that particular root node. Hope it is clear. So with this, we will be finishing our fourth module. Okay.